So in this week, we will learn about data pre-processing, and there will be 3 sections. First is how to handle the missing values, and the second is how to handle the aggregation and pivot. What is handling missing data? First, we are going to learn how to clean, and in the English word, it is homogeneous. So we want to make the data homogeneous. So we want to make the data is quite good for the analysis. And the real world data is dirty, contain noise, and complex. So that's why we need to handle the missing data due to the existing of noise and the complexity. So the question is, how can we pre-process the not ready data? Once you have your data, usually it is not ready for the analysis. And how do pandas work for pre-processing the data in Python? Okay, so we will learn those 2 things in this chapter. Okay, Chen Minyoung, I will check your attendance later. Okay. So this section will focus on handling the missing values. So what kind of missing values are common in real world data? And then how can we handle the missing values? And how do pandas work for handling the missing values? There are some conventions. Conventions. Do you know conventions? So it means there are some same rules. We know what is the meaning by the missing data, and other people also need to know what is the meaning by missing data. So missing data is a common problem. So everyone who learn the data science, they need to know this kind of problem. So the presence of missing data in a table or data frame requires some strategies. Okay. There are at least 3 strategies. Okay. So we call it, this is using a mass. Using a mass, it means we can use something like the global value. Okay. So using a mass that globally indicates missing value. So if there is a missing value, we change with one value that fits for that value. For example, if there are some data, so if you have your data and then you have gender, okay, and then if you know that there are some missing value about the male or female, and then missing, and then male. Okay. So if you know that this is about the military service, for example, so most of the people in the military service are male. So we put the male in any missing value. This is what we call as the global indicate, okay, or using a mass. Or you can choose a sentinel value that indicates the missing entry. Okay. So usually the sentinel value is something related to that particular data. For example, if you have your age, yeah, so if age is missing in some part, yeah, so you may use like the median, or you can use like the mean, yeah. Or you can use learning approach to replace the missing value. Yeah. So the learning approach is something related to the classification or clustering, or something is more learning before you decide the good value for data. So this is the explanation. Yeah. When you have the mass, usually it may involve appropriate values to indicate the null status. So maybe it is true, false, or 0, 1. Okay. So like I mentioned to you, male, female. Okay. Or we can use the sentinel value. So the sentinel value, it may indicate the missing value with some data specific convention. Let's say if we have integer, so missing integer, then you can use minus 9999. Yeah. So this is yeah, some people use this one to indicate the highest value or the lowest value, or maybe some rare bit patterns like this number 987654321. So this is not always available. Okay? So we can just use this one to indicate that this value is missing. Or we can you can turn out the missing value with the global convention. So we are going to learn NaN. NaN is not a number, yeah, or a specific value which is a part of the IEEE floating point specification. Okay. So this is what I explained to you. We can use mean, we can use median, or yeah, we can use any number to express the missing value. Or we can use the learning approach. It may replace the missing value with some machine learning. So if it is related with integer value, maybe we can replace with regression. If the missing value is nominal value, maybe we can replace with classification. Okay, so we will learn more this later part. So how pandas handling missing values? There is no such built-in notion of NA value for non-floating point data type. So what does it mean? NA. NA means not available. There is no such NA in the NumPy to indicate the missing value. So this is very important because in other programming language, let's say in R, you may learn about NA, or in Java, yeah, you may also learn about not available. Okay. So the pandas have different ways to handle the missing values. So the pandas will use sentinel values. So what is sentinel value here? They have a kind of specific floating value. They call it NaN. So I think the NaN in pandas is a very big value, okay? And this to indicate a very rare value. Okay? So if it is NaN, okay, it is special floating value. Do you know what is meaning by floating? Floating, yeah, any number with comma, with decimal. Okay. So maybe the number is like, yeah, something maybe like this one, comma, yeah, something like this one. Okay. So the number is very big. Oh, okay, thank you. Real number, yeah. So the number is very big, and this is very rare. You will not find this kind of number. Okay. So if the pandas shows NaN, it means it is for the floating value. But if pandas shows NONE, so it means known, okay, it is for the object or categorical value. So those are indicating the missing values, but they are different. Okay. They are different because the first is for the numerical data, okay, floating value, and the other is for the categorical data. Okay, please be aware with this one. So we have the known. Okay. So this is the Pythonic missing data commonly for categorical data. So the first sentinel value used by Panda is none. It is a Python singleton object that is often used for missing data in Python code. Because it is a Python code, yeah, none cannot be used in any arbitrary NumPy or pandas array, but only in arrays with data type object. So if you understand this one, okay, so none cannot be used in NumPy. None cannot be used in pandas. None is only available in Python. Okay. So let's say I have this NumPy pandas. I think you know this basic one. And then let's suppose I have array. Okay. And I have array like this one. The first element is 1. The second element is none. Okay. None is a missing value that is available in Python. But as I mentioned to you, when we use the none, it means it is for object or categorical data. What is NumPy? The word NumPy is to express the numerical. Okay. Okay. Thank you. Thank you. Okay. So, okay. Everyone already know. Okay. NumPy is numerical in Python. So the data should be numeric. Okay. When you use none, which is object or categorical data, is it correct? Yeah. You can find out. Yeah, it's not correct, right? Okay. Thank you. Thank you for your answer. So as you can see here, oh, the NumPy can detect the data known, and the data type is object. Okay, you can see that the NumPy can detect this known. So the data type object means that the best common type representation NumPy could infer for the contents of the array is that they are the Python objects. While this kind of object array is useful for some purpose, any operations on the data will be done at the Python level, and with much more overhead than the typically fast operation seen for arrays with native type. So what does it mean by this one? You can see something like this. I missed something. Oh, okay. No. Okay. So maybe the one that I explained to you is something related with the concept of the object. Okay. So the use of Python objects in array also means that you can perform the aggregation like sum, mean, okay, and across any array of with a known value. So if you have known, as I mentioned to you, it is for the categorical data. It is for object. And can you do with sum? Sum is a function for numerical data. Okay. Sum is for the numerical data. Meanwhile, the D type is object. Can we do sum for categorical data? Yeah, that's a big question. Because array, the NumPy, it should only have the numerical data, but they can detect object because it is from the Python. And if you run, then yeah, the result is error. Because there is one object is a known type. Okay. So you need to learn those kind of errors, because when you do with your Python, yeah, you will find some of this kind of experience. Yeah. So when it has errors, it means, yeah, you know that this kind of data is not correct, or there are some things that you need to improve. Okay. So this reflects that the fact that the addition between integer and known is undefined. So you cannot do 1 plus known plus 3 plus 4. So this is error. Okay. There is another kind of missing data. We call it NaN. So this NaN represents that the data is not a number. Okay. So not a number. Yeah, as I mentioned to you, it is a very rare pattern, like 8, 9, 9, 8, 7, 6, blah 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 blah. Okay. So it is a special floating point value recognized by all systems that use the standard of IEEE floating point representation. Okay. So if I change non-object into np.nan, what happened? If I want to see the data type now, it is changed to float type. So the np.nan, it can turn out the missing value into number, but it is not determined as a number that we can see. It is a number that is very rare pattern, because in order to do some operation, we need to have this kind of value to handle the missing data. So if you run this one, you can see that the data now becomes 1, and then NaN, and then 3, and then 4. Okay. So NaN, it is still as a number, because the data type is float. Okay. So notice that NumPy choose a native floating point type for this array. This means that unlike the object array from before, this array support fast operation pushed into the compile code. So you already learned from the previous chapter, there are some function that you can use for array. Okay. You should be aware that NaN is a bit like a data virus, okay, because it will infect any other object when you touch this data. Okay. So what does it mean by this one? Okay. Regardless to the operation, so this arithmetic NaN will be another kind of NaN, like say like this, 1 plus np.nan. Yeah, the result is NaN. Why? Because this is a kind of missing data representation, or it is a rare data, so you cannot get the result. But it is not error. Okay, the result is NaN. If you have the multiplication like this one, the result also NaN. It is not an error. So this means that the aggregate offers the values are well defined. They don't result in an error, but not always useful. So let's say if I have the value sum, value mean, value max, yeah, when I want to get this, yeah, all the results are NaN. So why we need to use this NaN? Yeah, because yeah, we need to handle the missing value. We need to put something so we can do the analysis. And NumPy does provide some special aggregation that will ignore these missing values. So if you have the missing values, you can ignore the missing value by using some function like NaN sum. So I think last time we already learned this kind of function, okay? NaN sum to express the operation when the data has not a number. This is also NaN min, NaN maximum. Okay. So when we have this NaN sum, okay, the data is 8. So 1 plus 3 plus 4, so 8. When we have np.nan min, we can find the minimum 1 and the maximum is 4. So this kind of function is to do the arithmetic operation and ignore the missing value. Keep in mind that the nan is specifically a floating point value. There is no equivalent nan value for integers. There is no equivalent nan value for string. Okay. So this nan is only for floating point value. So the nan and known in pandas, actually you can use it. Okay, and pandas is built to handle the two of them nearly interchangeably, and converting between them where appropriate. Let's say this one. Yeah, I explained this one. How the pandas will automatically convert the known or nan value, okay, when you have a missing value. Okay. So notice that in addition to casting the integer array to floating point, okay, so the pandas will automatically convert the known to nan value. There is another kind of programming language which is R. Okay. R usually expressed with NA. Okay. But in Python or if we use pandas, we have a sentinel or casting approach. Okay. So for example, if your data is floating, okay, then the pandas will automatically change to np.nan. If your data is an object, okay, then your data will be automatically changed to the known or np.nan. If your data is integer, then the data will cast to float 64 and the missing value will be np.nan. If your data is Boolean, true, false, yeah, so Boolean is true, false, it will be cast to object and the missing value will be directly indicated known or np.nan. Keep in mind that in pandas, string data is always stored with an object data type. Okay, so let's find one data in, I already put one more data file in the E-class. Okay, so there's one more file. Sorry, last time I didn't upload this one. You can get the file in the E-class. So name with missing. And as I mentioned to you, you need to put this file in the folder data. Okay. So if you are using your computer and you have your notebook files in one folder, so you can have one more folder data and then you can put all the data in that folder. So you can separate between the data and the notebook files. So I will run this. This is example of data miss. Okay, and then I have this read CSV to read the comma separated value. and I would like to see what is the content of this data miss. Okay, I have the name and weight, and then okay, I can see NaN. Okay, I can see also NaN. I can see also NaN. Oh, why they put the NaN in the categorical data? Yeah, this is automatically from the Python. Okay, because it is based on the pandas, so the pandas will automatically change whenever it is an object, and it is also a floating point. It will be automatically changed to NaN. Okay. If you want to take a look on the data, okay, so we have name and weight, and you can see it missing. It is missing, and then it is missing. Okay. So there are 1, 2, 3, and then when you see this one, yeah, it is NaN, NaN, and NaN. So pandas data structure have two useful methods for detecting null data. The first is null, and the other is not null. Either one will return a Boolean mass over the data. What is the meaning by a Boolean mass? Let's see. If I put is null, is null is only to show whether it is a missing value or not. The first is not missing. It is not missing. Okay, this is missing because it is true. It is not missing, not missing, not missing. Okay, it is missing because it is true. Not missing, not missing, and it is missing. Okay. What about not null? Not null means I want to see whether the data is not null. Oh yes, this is true. It is not null. It is not null. Okay, this is false. Then it means it is null. Okay. So null means the missing value or nothing. So this is the opposite of this is null. Okay. The is null and not null methods produce similar Boolean results for the data frames. Is only the opposite, whether it is true or false. And how to drop? Drop means how to delete. Let's say I have the missing value and then I do not want to use for the data analysis. Even though I already mask or I already replaced with NaN, this missing value should be deleted in order to produce a good result. So there are some convenient methods. We call it drop NA. It is to remove the NA or the not available values or the missing values. And there will be another method, we call it fill NA. So fill NA means I want to fill with a value. So for example, if I drop, so it's straightforward. All those missing values are deleted. And the deletion will be based on the row. So only Amy 65 and Daniel 68 will be kept. So we can have only this data for analysis. The other data or the other instance will be deleted. If I want to drop columns, what happened? Why? No data? Because every column has missing values. So all the data are deleted. Okay. So all data are deleted if we have the axis equal to column. So this drops some good data as well. Okay. So you might rather be interested in dropping rows or columns with all NA values, or a majority of NA values. So you can put something like how. You can put threshold, which allow fine control on the number of nulls to allow true. Let's say if I put how equals to any, so it means, yeah, it depends on the keyword, like I mentioned to you, axis equal to columns. Then I want to delete only the columns. But if I use the default, so the axis will be in the row wise. You can also specify all, which will only drop row or columns that are all null values. So let's say like this one. I put a new column. Okay, so the way to create a new column is like this one. I know that the column contains only name and weight. Okay. And then I want to create a new column. So I can use the square bracket. And then I create, this is a new name. And this new name will contain all as a, not a number, NaN. When you run this one, yeah, all the data are NaN, 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 NaN. Okay. So this is the original data. Emmy 65, Bob NaN, NaN 65, Daniel 68, and Esther NaN. Let's say I want to drop this on the axis columns, and how? So let's delete the column which has all not a number. So the column which is all NaN will be deleted. If I want to delete rows, yeah, this is the same with what we already saw before. Right? This one. It is deleted. Oh, wait. There's one something wrong. Or did I do something wrong? What happened? Wait, let me run again. Okay. So this is from the data. So let me use this. Okay, let me have the NaN, and then if I drop, okay, because once I drop the value, it will drop all the things. Okay, so let me just use this one. Oh, this one, because we have all the data has NaN. Okay, because the row has NaN. This row has NaN, so it will be deleted. This row has NaN. This row has NaN. This row also has NaN. So all the data are deleted. Okay. How about if I make a threshold? So I make a threshold when the columns, well, if I want to delete the columns, and then I put the threshold where the data at least contain minimum 4. Okay, so we have 1, 2, 3, 4. Okay, we have 4 data still available in this case. Then I will keep this column, and other columns will be deleted. And if I want to delete the rows, and I put the threshold equals to 2. Okay. So it means delete the rows with the non-null values to be kept is minimum at least 2. Okay. We have this row, and at least we have name and weight. Name and weight. So we have at least 2. That's why this rows will be kept. What happens if I change this threshold into 1? Then all data will be kept. Okay. Because if in every rows there will be only one none. Okay, so at least we have one data. 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 Okay. So you can change this one depending on your threshold. Okay, so you know already about the NaN, and you know already about the np.nan. And do you know the difference between dot sum and dot non-sum? So the dot sum is to calculate all the numbers regardless with the NaN. The dot NaN sum will remove the NaN. Is null and not null. It is to find whether the data contains null, and we want to find whether the data is not null. How will you delete the NaN value from your data? So we will use the function drop NA, and we learn many parameters about the threshold, okay, and about the axis. So you can determine which one do you want to refer to. Okay, we need to understand how to fill the null values. Okay. So sometimes, rather than dropping any values, you'd rather replace them with a valid value. So this value might be a single number like 0, or it might be some sort of imputation or interpolation from the good values. So you can do this in place using the isNull method as a mask, but it is a common operation to provide with fill NA. And it will return a copy of the array which the null values replace. Okay, so what does it mean by this one? Let's see. If I have this missing value, okay, and then I want to fill in with 0. So the data in the column weight, if there are some missing value, we will replace it with 0 with the fill NA. Okay, I think I will stop here because you need to do the course-based quiz.